Hello guys, welcome back to another week. Today we're going to be talking about piecewise functions. You may have seen this in Algebra 2. We're going over it again today fairly quickly. We'll be using these piecewise functions tomorrow in that lesson. So you're going to have to make sure you understand how to do this. So a piecewise function is a function that's made up of multiple pieces of other functions. I call them Franken functions just to be goofy because this topic always comes up in October, and I think a Frankenstein's monster was made out of pieces of dead bodies and a little creepy. So this is pieces of different functions. Each piece exists only in a prescribed domain, which means x values. You only use certain pieces of functions for certain x values. These pieces will never overlap. When you draw a graph, and this is primarily graphing, if you have one piece of a function that goes like this, and another piece of a function that goes like this, you've made a mistake because here they're overlapping, and that will never happen. I'll talk about that when we get into the actual exercises probably. Before I get into the worksheet though, I want to look at just a little bit of what a piecewise function, what it looks like, the mechanics of it, the appearance of it, and technically how it's supposed to work, like if you were making a table of values. So this is a three-piece function. F of x equals x squared for numbers that are less than 2, f of x equals 2 when x equals 2, and f of x equals x plus 3 when x is greater than 2. So a three-piece function here. So what would you do if you had to plug in numbers and plot points? Well, let's say you had to plug in a -1. You have to ask yourself, which piece does that -1 get plugged into? Is -1 less than 2? Does -1 equal 2? Is -1 greater than 2? Well, -1 is less than 2, so that means that this would get plugged into the first piece, which is x squared. So -1 squared equals 1. Now you plug in 0. Again, 0 is less than 2. That gets plugged into the first piece. 0 squared is 0. Plug in a 1. And again, 1 is less than 2. 1 squared equals 1. Now we get to 2. Is 2 less than 2? No. So we don't use the first piece here. Does 2 equal 2? Yeah, 2 equals 2, duh. So the value you put here is simply 2. Now let's plug in 3. 3 is greater than 2, so we plug that into the third piece. 3 plus 3, and you get 6. 4, again, 4 is greater than 2. You plug that into the third piece, and you get 7. So the output values that you get them by plugging them into the different pieces of the function. What's after the comma here tells you what is kind of the rule or the domain rule that you have to follow in order to get these values. All right, so let's look at these. We're going to use Desmos to be doing the graphing here. So if you have not installed Desmos yet on your iPad, get that done. So what do I need to do? I need to bring up Desmos, share the screen. I'm going to do this proportion here. Now, what would be nice is if you could type this in to Desmos over here on the right, and it would just draw the picture and you're done. Unfortunately, it's not that easy. For a two-piece function, you actually need to type in 2 lines. And secondly, it doesn't look, what you type in does not look exactly like this. Instead of w of x or f of x or anything like that, I just like to use y. So y equals 0. Now, next thing you see here is a comma. Do not use a comma. There is a comma button, but that will mess things up. So don't use a comma. Instead, you see this funny bracket right here? It's actually called a brace, not a bracket. So we're gonna omit that comma, and we're gonna put this in brackets. So to get a bracket, you hit the ABC button, the bottom left corner of the calculator screen, and that toggles between a calculator keyboard and then a regular alphabetic keyboard. And then on the alphabetic keyboard, the bottom row center is that brace. Go back to the regular calculator keyboard, and we can type in x less than or equal to -4. And what we see here is a piece of a horizontal line. And it comes up and it stops. Now let's type in the second piece. So I'm going to do y equals, and then I'm going to type in this function. So parenthesis x plus 3, close parenthesis, raise that to the 4th power. Now you see the cursor blinking up there. I'm going to move the cursor over. You just tap the screen. And now I'm going to put this, again, skip the comma. The comma will ruin everything. Don't put the comma. I'm going to put the brace, and then x is greater than -4. And so what we have is a two-piece picture. There's a horizontal line, and there's a line sort of shaped like a J. So let's duplicate this onto our paper. So we got this horizontal line that stops at -4, 0. By the way, what I'm doing, tap the line with your finger on your screen, and then just slide your finger back and forth, and it gives you all those point readouts. So my line looks like this. Now, this J shape, this is interesting. When I tap this and move my finger along it, when I get to the end, there is an open circle there. Oops, right there. And this has to be duplicated on your graph. So what are the coordinates of that? It looks like -4, 1 is a circle. And then, where does that minimum happen? -3, 0 is a minimum. So it comes down kind of like this, and then it shoots upward like that. But having this dot and that circle are critical in having your graph right. Now, if you go back to the original problem, the inequality with the equal sign will be the dot, and the one without the equal sign will be the circle, and that will always happen. So you can tell just by looking at your graph, your equation, your piecewise function, whatever you want to call it, you can tell where the dot and the circle are going to be. But if you use the Desmos screen, you have to tap your finger on it and then run it along the function, and it will eventually highlight whether there's a dot or a circle there. All right, let's check number 2 and see if I'm right. And I better be if I'm using a calculator on all these. And yeah, that looks good. All right, let's go back up and do number 4. So delete this. Y equals square root of x. Now, that cursor is blinking under the square root or under the radical bar. I need to move it over and then get my little brace and then type in x less than or equal to 3. And that gives me this little interesting shape here. It seems to start at the origin with a dot, and it ends at the point 3, 1.7, blah, blah, blah. So a little arc there. We'll draw that in just a second. Let's do the other piece. Y equals parenthesis x minus 3, close parenthesis, and that's squared. Go to the other keyboard and get my brace and type in x is greater than 3. Now, there's no equal sign there. It's just greater than. Oop, I missed a number. There we go. So this ought to end in an open circle. Does it? Yes, there it is. So about 3, 0. Oh, okay. Getting ahead of myself. So the blue section on Desmos is there at the origin. Oops. And then it ends at about 3, 1.7. So right about there, there's just this little arc. And then the green piece starts at 3, 0, but it's an open circle, and it's kind of half of a parabola that goes upward like that. All right, let's check number 4. And there it is, exactly the same. Okay, so this is how it's done. If you get it and you want to stop the video and get to work, that's fine. I'll just tell you that eventually I get to 3-piece functions, and the last one, number 14, is kind of special. So you might want to tune in for number 14, possibly. It's going to be like 13, maybe a little bit tricky. But yeah, I'll just keep plugging away. You watch as much of the video as you need to. All right, number 6. Y equals x squared, brace, x less than or equal to 0, and this one should end in a dot. It does. The second piece is y equals parenthesis x minus 1, close parenthesis, and that is raised to the 3rd power. Get my little brace in there, and I need x is greater than 4, or greater than 0. There is no equal sign there, so this one probably, yep, It's a dot. So we've got half of a parabola right here, and then this black shape is what we call a cubic shape, and it goes kind of like this and like that. So that is my graph of the piecewise function for number 6, and there it is. Close enough. Maybe my curve part isn't exactly the right shape, but it should have been a little more like this. But I'm not going to get picky. You don't have to get that picky when you grade yourself. What you do have to get picky on is the dot in the circle. Make sure you're getting that right. Number 8, our first 3-piece function. So y equals -2. So this is a constant function, horizontal line. Put in the domain, which is x less than -2. So it's a horizontal line that stops with an open circle. And then y equals 5, another horizontal line. Of course, right there it goes to infinity and negative infinity, but I need to type in my domain, which is -2 less than or equal to x less than 3. Oops, -2. There we go. Now you see it's just more of a line segment up there with a dot on one end, a circle on the other, which makes sense. Equal sign, no equal sign, dot, circle. And then the third piece, y equals parenthesis x minus 4, and that is raised to the third power. And then I have to put in the domain of x greater than or equal to 3. And here we have a cubic function that starts with a dot. So let's draw these. Horizontal line at -2 that ends right about there. Then a horizontal line up at -2,5 and ends at 3,5. -2,5 ends at 3,5, but with an open circle, like so. And then my cubic function, 3, -1, and then it kind of goes like this and like that. So let's see if I did number 8 correctly. And looks pretty good. Again, my curve is a little off for some reason. I don't know. I just don't do cubics really well. It should have been shaped more like that, but whatever. But what's really important, well, you have to have the shapes in the right place, and then circle, dot, circle, dot. When you check yourself, make sure you're getting that correct. Let's look at number 10. Delete all this. Y equals x squared, brace, domain of x less than 0. Second piece, y equals 2x minus 4. There should be, a slanted line. Brace, 0 less than or equal to x less than 4. So there's a piece of a slanted line. And then 5 is a constant, so y equals 5 should be a horizontal line. And then the domain, so I hit my little brace, x greater than or equal to 4. Here comes my dog. I don't know if you can hear his collar chain in the background, but there it is. All right, so we have half of a parabola. Oops. If I trace it, it's an open circle at the origin. So at the origin, I do an open circle and draw sort of half a parabola out here. And yes, that is the equation of a parabola. Then I have a slanted line that appears to go down to -0, -4 with a dot. And it ends at 4, 4 with a circle, like this. And then the horizontal line here, 4, 5, dot, horizontal line, like that. Have an arrowhead here. All right, let's check number 10, make sure I did that all correctly. Yep, there it is. Looks good. Number 12 will have a subtle difference to it, something that hasn't happened yet. So let's get into that, talk about it. 3-piece function, y equals 2 is a horizontal line. My domain is x less than -2. Second piece is y equals x. That's a slanted line. The domain is -2 less than or equal to x less than or equal to +2. Oops, I go back to the previous one. See that negative there? I forgot to type that in. What tells me that? Look at my graph. There's an overlap there. That lets me know I did something wrong. I missed something. Put that negative sign in, and now it's all better. And then the third piece is a rational function, y equals 4 divided by x. And now you see that cursor blinking down there? I don't want that. I want to move it over and then type in my brace, x greater than 2. So here's my three-piece function. The blue horizontal line ends in a circle. So right here at -2, 2, there is a circle and a horizontal line to the left. This slanted line ends in a dot and another dot. So it looks like that. And then this blue curve here ends in an open circle. But when we go to draw that, there's already a dot where the circle should go. So the dot sort of fills the circle. You don't actually have to draw the circle in this case. It just kind of runs out like that. So there is no need to put a circle there because the dot from the other piece kind of already fills it. Let's go check number 12 and you can see what I'm talking about right there. They did not draw a circle because the end of the other piece is a dot and it would fill the circle, so there's no need for it. So there is number 12. Let's do 14 and we are done. So three-piece function, y equals, first piece is a cubic, x cubed minus 2, and my domain is x less than 1. So there we have a cubic function that should end in an open circle because there's no equal sign there. Am I right? Yep. The second piece, y equals 2x minus 2. There we have a slanted line, but watch what happens when I do my domain. X equals 1. There is nothing left. There's nothing there. And that's because this represents a single point. So we'll have to really focus in on that in a minute. Let's finish typing the rest in though. So the third piece, y equals -6. Sorry, negative 6 for the domain of x greater than 1. And there we have a horizontal line. -6 is a constant. So a horizontal line at -6 ends in a circle. So both of these end in circles. So here we have a cubic that ends right there, passes through the y-axis there, sort of curves down like that. This is the third piece, a circle here and a horizontal line that way. So it appears that the second piece is missing. So the first and the third got graphed. Where is that second piece? Well, it's a single point, and there's a little quirk with Desmos. It does not like to graph single points very well. So here's what you need to do. You need to take this, go off to the side, and work it out. So 2x minus 2, x equals 1. That means plug in a 1 and work it out. 2 times 1 minus 2. That's 2 minus 2, which is 0. What that means is the point 1, 0, 1 is your x value, 0 is your y value, 1, 0 is a single isolated point on the graph. You go there on Desmos, tap it with your finger, nothing happens. Oops, it doesn't do anything. So Desmos doesn't do single points well. This whole idea over here has to be something that you do yourself then. You have to recognize that if you have x equal to a single point, that you're going to have to manually do that one. If we look at the answer, it is exactly that. So we have our cubic ending in a circle. The horizontal line starts in a circle and goes that direction, and then the single dot right there. Okay, well, that concludes this lesson. Do your best. Use Desmos. When you grade yourself, be real critical of whether you did the dots and the circles correctly. That's very important. If you have any questions, contact me through the normal means. Otherwise, I will talk to you